Radiosurgery and ophthalmic plastic surgery. Radiosurgery or radiofrequency is a method of cutting and coagulating soft tissues, directing high-frequency radio waves 2 to 4 MHz through the tissue cells. The radiofrequency unit produces a radio wave that is transmitted to a passive electrode by an active one. A thin wire tungsten electrode acts as the active part, and an insulated ground plate as the passive one. The passage of high-frequency radio waves heats up the tissues due to the natural resistance of the tissues to radio signals. The destruction and volatilization of the cells at the tip of the electrode is the result of the resistance and the heat produced, leaving behind a trail of dehydrated cells with consequent production of an incision. In comparison, electrosurgery or bovie-cautery or diathermy, invented in the 1920s by Dr. Bovie, involves the passage of low-frequency current, 0.5 to 1.5 MHz, through the electrode, which resists the flow of current and becomes hot. In electrosurgery, the heat, rather than the radio waves, is transferred to the soft tissue. The ideal frequencies of the radiofrequency unit employed in oculoplastics is approximately 3.8 to 4 MHz, which is the frequency of the Surgitron, the RF unit invented by Elman Company in 1978. If we compare all various methods, that is electrosurgery, radiosurgery, CO2 laser, and the scalpel, I would say the gold standard is the scalpel, which creates 0 micron of thermal damage to the wound, but does not provide any hemostasis. If we compare electrosurgery and radiosurgery using similar power densities and 0.12 mm tungsten electrode, we can see that with electrosurgery we get 1/2 to 3/4 of a millimeter of thermal damage to the wound edge, whereas with radiosurgery we get only about 1/2 of millimeters, so there's less tissue damage using radiosurgery. Likewise, radiosurgery produced significantly less tissue damage than KTP, YAG, or pulse CO2 laser. All radiosurgery unit comprise a transformer to change the main voltage to a high voltage and high frequency current. This high frequency current is then further modified by filtering and rectification to produce one of 4 radiosurgical waveforms: filter cut, cut and coag, coag or hemo, and fulguration. The filter cut, which is 90% cutting and 10% coagulation, produces micro-smooth cutting and mainly used for skin incisions, biopsies, and grafting. The cut and coag, which is 50% cutting and 50% coagulation, is mainly used for endonasal DCR, transconjunctival blepharoplasty, and excision of verrucae and nevi. Coagulation or hemo, which is coagulates vessels up to 2 mm, is mainly used for coagulation of soft tissues during bleph, ptosis repair, and correction of lid retraction. Fulguration, which causes the most lateral heat, is mainly used for electrode desiccation. There are many types of electrodes developed for radiofrequency unit. The fine wire electrodes, for extremely fine excisions and incisions. The round loop electrodes for looping off small eyelid neoplasms and obtaining biopsy specimen from bigger size neoplasm. The triangular or oval loop electrodes used for excision of raised and pedunculated skin lesions. The ball electrodes for coagulation. There is also the extra fine empire electrode, which is very useful in oculoplasty, which is narrow at its point but widens as it gets closer to the handle. The advantage of this design is that the micro-sharp tip concentrates the radio frequency energy, resulting in minimal thermal damage to the adjacent tissue, which results in a thin skin incision with minimal scarring. The Havate DCR electrode design for endonasal DCR and standard external DCR. The Havatecan endoscopic forehead lift electrode, designed for endoscopic radiofrequency assisted forehead lift. The key to the advantages of radiosurgery and its most efficient use is summarized by the concept of lateral heat spread. Using swift light strokes to minimize time of tissue contact and using a low power setting on the cutting mode will yield clean cutaneous incisions without impeding wound healing. Higher power settings and the use of the rectified waveform blended cutting and coagulation mode can be used without untoward effects when resecting orbicularis muscle or orbital fat. Lateral heat relationships: LH equals T multiplied by I multiplied by W multiplied by S. Below that is F. Lateral heat could also mean lateral damage. Related to time, so if you keep the probe to the tissue for a long time, you are spreading lateral heat. If you increase the power, you'll get more lateral heat. The waveform matters. If you use the filter cut, you get less lateral heat. But if in coag mode, you get more lateral heat. The size also matters. The thinner the electrode size, the less lateral heat. And the thicker, the more is the lateral heat. The frequency is inversely proportional. Thus, if there is increased frequency, there is